Hi everyone, I'm Shubhani Ramalingam from the Department of Electro-Optical Engineering. I'm currently pursuing my PhD under Professor Chen Long Chen. Today, the presentation is about fiber optic sensors. We are going to discuss about various fields that have been using fiber optic sensors as a major input. In this presentation, we are going to see about introduction, structural health monitoring, working principle of fiber optic sensors, optical fiber humidity point sensor, railway structure health monitoring, interferometric fiber sensing, hollow core photonic crystal fiber gas sensing, summary, future scope. Introduction. Uh, we all know about fiber optic sensors have been widely used nowadays. They have an advanced sensing that utilize optical fibers to detect and measure various physical parameters such as temperature, pressure, stress, strain, displacement, or chemical composition. Their unique operating principles based on light transmission and manipulation make them highly versatile and desirable in various industries and applications. Here are some features of a fiber optic sensors. Uh, they are namely high sensitivity, immunity to electromagnetic interference, compact and lightweight, remote sensing capability, chemical and environmental resistance. In high sensitivity, they can also detect minute changes in the environment due to their reliance on light waves. Immunity to electromagnetic interference, that is EMI. Uh, Unlike traditional electrical sensors, fiber optic sensors are unaffected by EMI, making them suitable for challenging environments. Compact and lightweight. Optical fibers are small and lightweight, which allow for their integration into confined spaces and portable devices. Remote sensing capability. Fiber optic sensors can also transmit signals over long distances without significant signal degradation. Chemical and environmental resistance. Their materials are designed often make them resistant to harsh chemicals like high temperature, humidity, air, and moisture. Let's see about structure health monitoring. This fiber optic sensors play an important role in uh, structure health monitoring because the in the imitation of the human nervous system, they can able to notify us the changes that happens in our nervous system, that is abnormality in our nervous system. This SHM system consists of sensors, data acquisition and transmission system, structural warning and assessment system, and also they can store the data that has been collected in our structural health monitoring. The implementation of this system relies heavily on the support of sensing technology. So, this FOS plays a vital role in our structure health monitoring. Working principle of FOS. Uh, in this FOS system, they have five parts like light source, optical fiber, sensing head, photo detector, and demodulator. The basic principle is when we input a light source into an optical fiber, it will be transmitted through the sensing head. Inside the sensing head, the externally measured parameters all interact with the light, causing the optical properties of light such as intensity, phase, frequency, wavelength, polarization, etc. to change. This modulated signal light is then sent through the optical fiber to the photodetector and demodulator, and we finally obtain the measured parameters. This is how the principle of GFOS works when a light source is instant into the sensing head, and then there will be changes created uh, that will be directed by a director, and then the demodulator will give the output results of the fiber optic sensors. Fiber optic sensors in agriculture. In agriculture, fiber optic sensors are primarily used to monitor soil moisture levels, allowing farmers to precisely control irrigation systems by detecting which areas of the soil need the water most, thus optimizing water usage and improving crop yield. They can also be used to monitor soil temperature and potentially detect root system health and location by sensing changes in soil conditions around the root. Uh, Here are some features about fiber optic sensors in agriculture. Precise soil moisture monitoring. By measuring changes in light transmission through the fiber optic cable embedded in the soil, the sensors can accurately detect variations in moisture content, enabling targeted irrigation. Non invasive monitoring. Fiber optic sensors can be installed directly into the soil without significantly disrupting the growing environment. Multiple sensing points. A single fiber optic cable can be used to monitor multiple locations within a field, providing detailed data on soil conditions. This can give detailed data about the soil conditions so that we can uh, notice the default that has been happening in our soil condition. In the real-time data, fiber optic sensors can provide continuous data on soil moisture levels, enabling a timely adjustment to irrigation practices. Fiber optic sensors in a structure health railway structure health monitoring. Fiber optic sensors plays a vital role in our railway systems because in recent days in India there are a lot of accidents happening in the railway system. Uh, so that using FOS we can able to reduce the instant that is happening in the railway system. A large number of fiber optic sensors have also been used in the railway systems. Similarly, they have been used to measure strains in a railroad concrete rail sleepers also. Interferometric fiber sensing. Interferometric fiber sensing is also a powerful and versatile technique that have been used a variety of physical parameters such as temperature, pressure, stress, strain, displacement, and refractive index changes by utilizing the interference of light traveling through the optical fibers. This sensing technique relies on the principle of interference, where two or more beam of light combine together, producing a patterns of constructive or destructive interference. So that based on the phase shift introduced by the external influences, they can also use to sense the changes that have been happening in the regular system. Hollow core photonic crystal fiber gas sensing. Uh, this system helps the photonic band gap effect, where the periodic structure of the fiber guides light by creating a band gap that prevents a light from propagating in a certain wavelength. The specific arrangement of air holes can also be engineered to support guided modes that are well suited to transmit light in the hollow core. While minimizing this loss and dispersion, this photonic crystal gas fiber sensing works well uh, with the system. Summary. The feasibility and potential benefits of integrating these two types of sensing technologies, including mutual verification of measurement reliability, simultaneous information on changes inside and outside the structure, and also more accurate safety assessment and future prediction can also be handled. This integrated approach is relatively recent but can significantly evolve and attract the attention of researchers in future. Let's see the future scope of fiber optic sensors. Advancement in sensing technology. Miniaturization in integration is an ongoing research enabling the development of compact and integrated fiber optic sensors that can also be embedded into various systems with minimal impact. Multi-parameter sensing. Future sensors will be able to simultaneously measure multiple parameters like temperature, pressure, strain, vibration using a single optical fiber. Enhanced sensitivity in material science and signal processing will further increase the sensitivity and accuracy of the fiber optic sensors. Environmental monitoring. Real-time monitoring of pollution levels like air, water, noise, soil using distributed fiber optic sensing systems. Uh, Using this early detection of natural disasters like earthquake, landslides, tsunami through geotechnical fiber optic networks. Emerging research areas in this distributed fiber optic sensors for a long range applications and biochemical sensors for detecting hazardous substances in industrial and public safety. Small grids and small cities also utilize fiber optic sensors for real time monitoring and automation. Thank you.